Welcome to Spring LIB.
In this exercise, we have a ball that's kicked towards the playground of a school, and the playground is located on the roof. The playground is protected by a wall that's 7 meters tall and is located 24 meters away horizontally from the place where the ball was kicked. The playground itself is located 1 meter below the wall, so 6 meters above the ground. And we have the information that the initial angle, theta, with which the ball was kicked was 53 degrees, and the total time it takes for the ball to reach a point just above the wall is 2.2 seconds. So in question A, we have to calculate what is the initial speed v0 with which the ball was kicked. So in order to answer this, I'm going to look at the second equation that I have highlighted here in red. That's the equation for the x-coordinate of a projectile. And I'm going to set up a coordinate system whose origin is exactly at the place where the ball was kicked, and the y-coordinate points upward. So this here is the coordinate system. And notice that in this coordinate system, x0 is 0. That's the initial position of the ball. So what we have is that x, the x-coordinate of the ball, is v0x times t, and v0x is v0 times the cosine of theta. Okay. Now we know that when x is equal to 24 meters, t is equal to 2.2. Okay, so I can isolate v. V is equal to x divided by cosine theta times t. So this is 24 meters divided by the cosine of 53 times 2.2 seconds. And this is equal to 18.13 meters per second. Okay, this is the initial speed. In question B, we have to calculate the vertical distance from the wall, the vertical distance by which the ball clears the wall when it's passing right above it. Okay, so we have to calculate the y-coordinate when x is 24 meters. Okay, so let's do it in question B. We have that when the ball is clearing the wall, when it's right above the wall, t is equal to 2.2 seconds, and y is equal to y0 plus v0 yt minus 1/2 of gt squared. Y0 is 0. V0 at y is v0 times sine theta times t minus 1/2 of gt squared. So now we can substitute the numbers. V0 is 18.13 meters per second. I'm gonna leave it implicit. Times the sine of 53 times 2.2 minus 1/2 of 9.8 times g, which is, I'm sorry, g is already 9.8, of course, and t is 2.2 squared. So y is equal to 8.14 meters. Okay, that's the y-coordinate of the ball. So the distance from the wall, delta y, is just y minus the height of the wall. So this is 8.14 minus 7, or 1.14 meters. Okay. And in question B, we have to calculate, I'm sorry, in question C, of course. In question C, we have to calculate how far from the wall the ball reaches the playground. So we have to calculate this distance delta x here, okay, the distance between the wall and the playground. In order to do that, first we need to calculate at what time the ball reaches the playground, and then we can just substitute in the formula for the x-coordinate. So first of all, I'm going to use the equation for the y-coordinate in order to find the time at which the ball reaches the playground. So notice that the playground is located at 6 meters above the origin of the y-coordinate. Okay, so 6 meters above the ground. For that reason, y equals 6 meters. And we have the equation y equals y0 plus v0 yt minus 1/2 of gt squared. Y0 is 0, so it's 6 equals v0 is 18.13 times the sine of 53 times t minus 1/2 of 9.8 times t squared. Okay, so I'm just gonna simplify this a little. I'm gonna write this as 4.9. Notice that I'm multiplying it all by -1. T squared minus 14.48t, because 14.48 is 18.13 times the sine of 53 plus 6. Okay, notice that everything here is in the international system of units. That's why I'm not writing the units explicitly. And now we can solve this equation for t. So t, notice that this, I can write this as a t squared plus bt plus c. Okay, so a is 4.9, b is minus 14.48, and c is 6. And the solution is, according to the Bhaskara formula, is minus b, so this is plus 14.48, plus or minus the square root of b squared, so this is 14.48 squared, minus 4 times a, so 4 times 4.9 times 6, divided by 2 times a, so this is 2 times 4.9. So we have two possible solutions, one with the plus sign and the other with the minus sign. Notice that according to the figure, I'm just going to redraw it here, we have something like this. This is the trajectory. The minus sign will be the solution for when the ball is right here, it crosses the y equals 6 line for the first time, and the one we are interested in is when the ball crosses the y equals 6 line for the second time. It's when the ball reaches the playground. So for that reason, we are only interested in the plus solution. Okay, so I'm gonna erase the minus sign, and we can just carry out the calculation now and get that t is equal to 2.457 seconds. Okay, and x is equal to v0 times cosine of theta. Actually, here it's cosine of 53 times t, so this is 18.13 meters per second, times the cosine of 53 times 2.457 seconds. And here we have that x is equal to 26.8. 26.8 meters. And we just want the distance from the wall, so the distance delta x is x minus the distance between the place where the ball was kicked and the wall. So this is 26.8 minus 24, which is 2.8 meters. And this concludes the exercise.